Good morning, everyone. This is Bruno from Famic Technologies Automation Studio. I'd like to thank you all for attending this third webinar of our series on Automation Studio 8.0, What's New. So here's a list of the webinars that we have. Again, if you've attended any of the previous webinars, you should have received already a copy for a link to be able to access those videos. They will be posted on our website. Currently, the webinar that we have today is on the new GRAFCET and SFC modules that are available in Automation Studio 8.0. This is a quick overview of the agenda today. So we'll be going through what's new in those libraries according to the standards that they've been built upon. And for any questions, feel free to use the questions box during the webinar. We'll try our best to answer all your questions using the Q&A tool over the course of the webinar. It's preferable that you use the question box instead of raising your hand. It'll be easier for us. And then what we'll be able to do is, based on pertinent questions that are asked, we'll be able to run through them at the end of the presentation. We'll maybe reserve a little bit of time for some Q&A. So again, we hope you enjoy all of the webinars that we've done and that you enjoy also the webinar that we have today. Without further ado, I'll pass things over to my colleague, Shane, who will start the presentations.
Hello everybody. Today we're going to be looking at what's new in Automation Studio 8.0 with relation to the GRAFCET and SFC standards. To begin with, we'll start with GRAFCET. Now, the new workshop in Automation Studio has been designed to be compliant with the IEC 60848 standard. This is a standard relating to GRAFCET, which is a language that is generally used for specifications rather than programming. The SFC standard that we'll see later is more for programming. Now, what this workshop allows you to do compared to our previous workshop is that we now have some new commands for creating partial graph sets and forcing, enclosure, and macro representation commands. So we have here, you see here in the little screenshot here, these new tools that are available in the ribbon for the different types of partial graph sets that you can add. To be able to use these partial graph sets, we've also had to add new step symbols. So previously we had just standard steps and initial steps. So now if we look in the toolbar here, you see we have different types of steps that are added to be able to use the forcing and enclosure graph sets. So we can also add different actions in a step of different types. So here you can see we have continuous action, stored actions, and forced actions. And these have different modes that we will see later on. Additionally, we have also added new operators. So to be able to implement some of the different functions of GRAFCET, we have different operators that are available. So we'll start off just by a brief overview of what the global GRAFCET looks like. So here we could have a few partial graph sets. So we have just one here, one here. And then we have another partial graph set here. And all this together is considered to be a global graph set. So with each of these partial graph sets, if we just zoom in here, a normal graph set would look something like this, where you have your initial step, transitions, and all the various steps as you go through. If you use a forced partial graph set, you can have your normal graph set on one side, and then beside that, you can have a force function on this second partial graph set. So when you want to add in one of these, so I'm just going to remove this just to show you how it is added. It's just a simple matter of drawing a box. So you click on the tool on top, you draw a box around it, and that's your new graph set has been, your partial graph set is now a forced graph set. And when you click on the box and move this around, all of the components within it are moved along with it. If you want to remove it, then you hold Shift to drag this outside. So we just put this back to how it was previously. So this is the forced partial graph set. For an enclosure, so with the forced partial graph set, before I move on to the next one, there are no particular steps required within the forced partial graph set. It looks pretty much like a normal graph set. if we look at an enclosure partial graph set, we'll see we still have the enclosure. So we add this in the same way as we did for the forced. We just draw the box around it. But you'll see within the enclosure, we have some of the steps here have an asterisk next to them. So this is to indicate a link which is activated once the enclosure becomes activated. If we look here on this one, we have a standard activation link. So this one is activated when the enclosure is activated. The one above is activated when the GRAFCET, when the simulation runs, and also whenever the partial GRAFCET is activated. Next, we look at the macro step. So again, this is similar. You draw the box using this tool here. For the macro, what this represents is an expansion of a step on the normal GRAFCET. So we don't have it here, but if we just change this one, we can change this to a macro step. So what this would be then is, as we're running our normal GRAFCET, we could step in here, then this will be expanded into the macro step. We'll see this in more detail later on. But all of these are added from the toolbar, and then you just need to set the appropriate steps in your normal GRAFCET to activate them. So we'll start by looking at some of the forcing commands. So here we have our normal GRAFCET, and we have the forced GRAFCET. So for the forced GRAFCET, you need a command in your normal GRAFCET which will activate the forcing on that GRAFCET. So different types of command are available. But if you look at this one here, when we want to, let's just say we'll start with the first one, which has nothing yet. So if we look at this here, we can add a function which will be to force, and then we can select our enclosure, and then within that we can select the different options. So we'll go through those in the other ones. I won't save those changes there. So in the first one here, in step 7, we have it forcing on G1. So you can see here the name of the force partial GRAFCET is listed at the bottom here. When you go into the properties of your step, you can see that the forcing order is going to take the name from this one here. And then within here, when you click, once you have selected your forced partial GRAFCET, you can then click on one of the forcing functions to do. So this one here is an empty brackets. This one will force it to the empty state. So what that means is when you activate step 7 here, all of the steps here will be forced to off. In step 8 here, we have this one forcing 2 different steps. So here we have just X2 and X3 forced, but you can have any combination of the different steps to force just by selecting them there. And we'll just close that. We won't save the changes. So when step 8 is activated, both step 2 and step 5 will be activated. This one with the star is going to force into the current situation. So whatever situation the GRAFCET is currently in, it will maintain that situation. And then the last one is to force it to the initial state. So in this case, that would be step 1 here, which is an initial step. So if you run the simulation and just see an example of how that works. So by forcing the step here, you can see that once this is activated, these steps are all emptied. If I do the same here, I force this one, you can see that it forces into steps 2 and step 5 and so on. So you can see what the other ones would do similar things. One thing to note with this, so when we create our forced GRAFCET, we can double click on it to open its properties. You can see that it has a hierarchical level. This actually should be a hierarchical level of 1. So normally with the forced GRAFCET, by default, the standard steps, if they're not inside an enclosure or any of these elements here, they're considered to be at hierarchical level 0. So this is hierarchical level 0. It can force something of level below it. So in this case, this is level 1. So it can be forced by the steps here. The next, we're going to look at the enclosure command. So we have some examples here of an enclosure command. The enclosure, like I said earlier, is activated when the enclosing step is activated. So in this case, if we look at this step here, step 6, it has a slightly different symbol. If we just look at the different types that are available, it's the initial enclosing or standard enclosing. Either of these can be used to activate an enclosure. So in this case, it's an initial enclosing, so it's both an initial step and an enclosing step. So when you start the simulation, this step becomes active. When this step is active, the enclosure also becomes active. And if we look here at the first step, you can see that this one has a star next to it. So as soon as this activates this enclosure, this step will become active. This one also has an initial step here, step 3. So when the simulation runs, this would normally become active, but because of the status of this one here, this one will activate step 1. We can also see here, it's done slightly differently. So we have our initial step 19, then our step 10. Once step 10 becomes active, this will activate step 13. So step 13 is a link. So let's just go inside here and have a look. The standard activation link step, or we could have had an initial activation link step. So if we zoom out, we can see we have one here. So this one is an initial activation link. So when simulation starts, it will be active, but also when this step is activated, it will reactivate. So let's just run simulation and see how these go. So this one, if we look at it, it starts initially. So because on the first run, it doesn't activate, let's just force this so that it loops around. Now, once this one becomes activated again, this step becomes activated. And while this step is activated, we can run through the different transitions here. But as soon as this step becomes deactivated, this enclosure also becomes deactivated, so all the steps are off. That we can see here, so far this step, the initial step is on, the enclosure step has not turned on yet, so if we force this one, then this one becomes on the linked step. And here on the initial setup, then this one becomes active, only in the case that this one is also active. So if we force it again, it turns off. So we can stop the simulation there. Next, we're going to look at the macro steps. So what the idea behind a macro step is that you can use it to simplify your graph sets. So if you have a long series of steps, you can break it down into subsections. So for example, you might have machine 1 doing some job, machine 2 doing a separate job, machine 3, and so on. And each of these machines, so let's just say this is machine 7, we can divide it up. So to break down when this machine is doing what it's doing, we can break this down into the different steps. So it just makes it a bit easier to follow the main structure of your program here. And the way this works is with your macro step. So again, you need to define it as a macro type. You will then in here select the graph associated with it. So in this case, you see it has the number M1 and it is linked. So you can see here, it is linked to step M7. And then within the expansion, we need to have an in step and an out step. So the first step in the expansion needs to be the in step, and then the last step needs to be the out step. And when we run the simulation on this, so if we run force simulation and force the transition there, we're now activated our macro. Now, if we try at this point to force this one, we will see is that nothing happens. So because this is essentially this step is enclosed in here, we have to run through all of the steps in here before we can transition out of this step. So we would have to force these one after another. Obviously, you would run this normally, you would have some other operation going on in the background that would cause those transition to change. But here I'm just doing it manually just to demonstrate. So we had to run all the way to the end. And then once this transition became activated, we were able to go to the next step. So that's the macro step. Next, we're going to look at some of the different properties of the actions that are new in this version as well. So on top of having these new functions here, we've added new modes for the different steps. So if we look at the first one here, we have, I'll just grab a new step. We create a new step. When we want to add in a new action, we click on the plus here, and then we can choose from 3 different modes. So just delete that one. So this one here, we're looking at the first mode. So we've already defined an action inside here, and it's been set to continuous mode. And it's also set without any assignation condition. So what that means is that when this step is activated, or while it is activated, the variable c and v will be true. So we can see this here. We have a little truth table here that describes it. So for the duration of the activation of step 2, the output variable c and v will also be true. As soon as the step becomes deactivated, the variable will be deactivated. Next thing we can have is a logical expression. So again, this is a continuous mode action, but here we have an assignation condition. So in this case, rather than having the variable, so in this case the output variable is down, rather than it being true immediately on activation of the step, we have some requirements for it before it will become activated. Now here we have it set up so that it's true when these conditions are met. So when not sensor A or sensor C and sensor B are true. So we'll just look at that before we go too far. You can see that they have that condition. So the not, we have the bar on top to indicate not, sensor A or sensor C, and sensor B. So the and is replaced here by the asterisk. So when you want to create these, you can type them in. So if you already have your variables configured, sensor A and sensor C and so on, you can type them in. Or let's just say I'm just going to delete this one here. You can use the different functions that are available here. So in our case, we have sensor B, which has already been created. We can click on this. We can look for our sensor B, and we can just add it in there. Just need a little space in there. And then that's corrected. In this case, you can add either using the alias or the name. So in this case, by using the alias, it's added the 2 quotation marks. If you've used the name, it will add it without. Either one works fine, but it just has a little difference there. You could also create your own variables. So if you don't have the variable already created, you can click on this button here, and this will allow you to add variables of different types. So this is standard in Automation Studio. There's nothing new here, so not much to show. The last thing here, the last button that we have here is the f of x. And this allows you to add in different operators. So you can see here we have the not operator and the and operator. You see the list of all the different operators that are available there. I could just click on that and add in a different operator. So I won't do that. I'll just delete that out of there. But all of the different operators that you can use are available in there. There's a few different tabs. In this case, we have 2 tabs. We'll see in some of the other steps, some of the other functions, that there are different buttons that you can add depending on the field that you're trying to complete. So here we have basic logical expressions that are available. So we can click on the check mark and validate that. So if we look at what this actually does, so while step 5 is active, and we need also sensor B needs to be active, so at one of these sections here, and then sensor A or sensor C not active, in that condition the variable will be true. So here sensor A is not active and sensor C is not active, so it becomes true. The next variable is time dependent. So in this case, we look at it here, we can see we have our output variable again. So rather than having a logical condition, so the different options that are available here are logical expression we've just seen. Time dependent is this one, delayed and time limited. So time dependent is dependent on a timed variable. So when the variable is true, in this case, after the falling edge, it becomes, the output becomes true. Or it's after the rising edge, I think in this case. So here, if we look at the variable, the output variable is up, the time variable is PB1, and the step is X9. So when the PB1 is true for 1.5 seconds, 1.5 seconds later, this becomes true. And then as soon as this falls to 0, the output variable becomes false. And you can do it multiple times in a cycle. So while X9 is true, you can push the button multiple times and the variable will become true. In the second case, as soon as the X9 becomes false, even though the push button is still maintained, the output becomes false. Next one here is we have delayed. So this is just delayed directly. So once the step becomes active, the output variable is called forward, and then 3 seconds later, the output variable will become true. So here the step becomes active. 3 seconds later, the output comes true, and then as soon as the step is off, the variable goes off. And here we have time limited. So in this case, the output variable will stay true for a certain duration. So backward becomes true as soon as the step is turned on. It stays on for 2.4 seconds, which is what we specified in here. So we have here 2.4 seconds. So as long as the time hasn't elapsed and the step is still activated, then the output variable will stay on. So if the step stays active for less than 2.4 seconds, it will still turn off as usual. Next, we're going to look at here. So we have stored mode activation. So for all of these on the left here, the continuous mode, they're only true for as long as the step is active. Some cases a little bit more, a little bit less, depending on other conditions. The stored mode, once the condition of activation has been met, the variable stays until some other step activates or deactivates that variable. So in this case, let's just look at what this looks like inside. We've chosen here stored mode. So previously we had continuous. We select stored mode, and then we can have different conditions for when the variable gets stored. So this one here we have on step activation. So as soon as the step becomes true, the action that we have suggested here is executed. In this case, it's an integer addition, but it could just as easily be a Boolean or any other type of operation. So here what's happening is we're setting the value of set point to whatever value length had and adding 3 to it. We can see here, you might see, I can't remember what the steps were on the other one, but you can see here there's different values here for the different actions. So what happens here in this case, once step 3 becomes active, well, prior to it becoming active, set point has some value, which we call current value. As soon as it becomes active, set point is set to length plus 3. But then when x3 goes to false, set point keeps that value. So whatever value got assigned here keeps that value unless something somewhere else changes it. Similarly, we have here, so this is on deactivation. So at this point, we have coil A is set to go to 0, coil B is set to go to 1. So in this case, they both change at the moment the step X7 becomes false, so deactivated. This one here, we have execution on event. So here we select the on event and we can choose what the event is. So that will cause this to happen. So this is a logical variable, Boolean variable. So that will determine when we're going to change the value of the variable. So here in this case, We have it, what did we say we have? So LS is up and the trigger on LS down. So when LS goes down, yes, so not, okay, it's in French here, but you can see when this triggers here. There's different conditions that you can set. So there's a lot of flexibility in these here that you can create all sorts of functions here. You can falling trigger, rising edge trigger, and different conditions. So as soon as that event occurs, then the action will be carried out. This is a different version of the same sort of thing. In this case, we're using real values. So it's not a Boolean, but at a certain point, once the event, that's the speed. So the speed is, well, not the speed is greater than set point. We will perform the action of setting the distance equal to position A minus position B. So when the speed drops below the set point, that's when we set the value. There's another function here. This is an execute, so you can do like APIs and all sorts of things there. You can there's a lot of different functions that are available here. If you just look some of these, execute can execute all sorts of APIs or open web pages or things like that. Here we're kind of looking at what we've seen already. We have the different forced mode actions that you can apply. So if you go to mode forced, then you will choose the forcing. So in this case, it's the G2, and then within that you can choose what exactly it is that you want to force. Forgot to mention it earlier, but with a lot of these, with all of these steps, you have activation times. So you have a maximum activation time and a minimum activation time. These can be useful if you're monitoring a system. Say an event is supposed to take a certain amount of time, plus or minus, and if it happens too quickly, then you know there's some kind of a failure, or if it's taking too long, you might know you have a different kind of a failure. So those parameters here can be monitored to check if your system has run the way it is intended to. We won't see that in here. I won't have time to go through all of the details of the new workshop, but that's a new feature that's there. Just to mention that we do have the help. So if you do need more information, you can see you have help on the IEC 80848 workshop is available. We have a whole guide explaining even more detail than what I'm showing here. Next, we're going to look at the transition properties. So there's a few different properties you can set for transitions. So the first one is always true. Well, it's pretty straightforward. You can see what the different options are here, but basically always true will assign the value to 1. So as soon as this step is completed or activated, this transition will become true and will pass to the next step. You can add a logical expression. So this is the standard way of doing it for a transition. You can add in whatever conditions you require before you pass to the next step. So it could be cylinder has reached end of stroke or something like that. In this case, you're checking to see that a start push button or something has been pressed and the initial conditions have been met. And then lastly is the time dependent. So here you can set the transition will activate once obviously the variable has become true, and then in this case after 2 seconds after the rising edge. So in this case, 2 seconds after this variable becomes true, the transition becomes true. You could also use the falling edge, or the variable itself here could be the activation step of the activation variable of the previous step. So in this case, you could have a step that stays true for a certain amount of time. So that's it for the GRAFCET. So now we're going to look at the SFC module. We'll just open up our diagram here. So the SFC, again, it's a new document workshop type that's been added to this version. And the SFC is based around the IEC 61131 standard. So this is in comparison with the GRAFCET, this is dedicated for programming, whereas the GRAFCET, like I said, is for specifications. So what is different in this? So we see we have the same types of step that are available as in standard. So our previous SFC module, it just has two types of steps. So it has a standard and initial step. But what it does have that's different are step qualifiers. So if we look at it here, for example, we have step 3, we have an N and an L, which we'll explain in a little bit. But these are qualifiers that you can set for each of the actions in a step. You can declare Boolean type actions, but you can also declare non-Boolean. So the non-Boolean in this case allows you to do more programming type operations. So for those operations, you can use either structured text or ladder diagram language. Now the SFC standard, so the SFC, the IEC 61131 allows for other types of non-Boolean action. But for the moment in Automation Studio, we're just using structured text and ladder diagram language. The ladder diagram language that's available is any of the ladder diagrams that we have available in Automation Studio. So we have, if I just look at one that we have here, if we look at the workshop here, we have Allen Bradley ladder, IEC, and so on. So the different standards that are available for ladder diagram, those are all available for your ladder diagram in the structure or in the SFC. We have a lot of new operators that have been added. So we've seen for the Graphset, we have operators that we added. For SFC, there's a lot more. So we can see we have the different tabs, the different categories of operators that are available. So we look at we look at the step qualifier. So the way this works is when you create a step, you can, here we have a new step. You could create an action by clicking on the plus button here, and then when your action is created, you get to choose from different types of qualifier. So we'll go through them all fairly quickly. These are all defined in the IEC standard. So we haven't invented anything new here. So if you have the IEC standard, you can always refer to that for the full description of what each of these are, what they do. But basically, just to go through them quickly, we'll see them here, but we can see the list of them all here. Actually, we see on the next diagram, I'll go through them in more detail. But basically, you have non-stored. So that's the variable is active while the step is active. You have set here, where it allows you to set a variable, which can then subsequently be reset by using the reset variable. You have time limited, which is active for a certain amount, time delayed, and so on. Actually, we'll just go through the next slide. It's just easier to see exactly what's happening with each of these. So if we look at the non-stored here, we look at a little chart. We can see that for the duration of activation of the step, we have the action N here is active. Then so we're just showing here the transition afterwards. As soon as the following transition becomes true, the action N becomes false. Here we have a set followed by a reset. So in this case, on step 13, as soon as it becomes active, the variable action S becomes true, and it stays true for the intervening period until in step 40. So at step 40, as soon as it becomes true, this action is executed, and the action S becomes false. So you can see here at X40, action S becomes false. If we look at time limited, so this becomes true on activation of the step, and then it stays true for a duration specified in it. So if we look here, when you choose time limited, you set the time for that step. So here, action L will stay true until for 1 second. Time delayed is similar, except rather than it becoming true immediately on activation of the step, there's a little delay before it comes active, and then it will stay active for as long as the step remains active. Stored and time limited. So in this case, it's stored. So on activation of the step, it's stored for a certain duration, or it can alternatively be reset by another variable. So if this was to occur before the time had elapsed, the variable would be reset. But in this case, in this scenario, the time is 1 second is elapsed, so the reset actually doesn't affect it. If this was maybe 1 hour or something, then by the time this X6 has become active, then the step will either the variable will be reset. Stored and time delayed, so this takes a delay before it gets stored, and then it gets reset as any gets reset by the reset action. Time delayed and stored, so this is again, it's similar. So it takes a certain amount of time before becoming active, and it is reset by the reset function. So here you can see the chosen here, the delayed, time delayed and stored. Here on the right hand side we have different pulse types. So we have the idea of a pulse is that if you want to just reset something, so you have another device or a counter or something that you want to reset, you just need a very quick signal to deactivate it or to activate something. So you can use the pulse. You can use it on the pulse on a rising edge, so as the step becomes active, or pulse on a falling edge. One thing to be wary of for pulses is that if you have multiple pulses, or if you have a large graph set with different elements with different pulses, you need to be careful of the order that they carry out in. So the step, the pulse here, as you can see here on the graph, it indicates that it's just for one cycle of operation of the SFC, so the shortest duration time. So if you're running a graph set that's quite large, you need to be sure that, for example here, step 11 is supposed to run before or after step 1, that there's not any kind of interference between the pulses. So that's the different qualifiers for each one. Next, we're going to look at structured text. So just to go back actually to the Boolean action, for each of these are Boolean. So the type of step that it is Boolean, and then it has the different qualifiers. If we look at the other ones here, so if we look just say the first one here, we can see we've unchecked the Boolean option, and let's just add one in just so you can see. But when we add in a new step, by default it's Boolean, the action is Boolean. We can uncheck this, and then we have the option to choose the language. So here we can choose structured text or any of the ladder languages that based on whatever ladder technology you have in your license. Those are the options that you'll see there. So we can just delete that. So here we have just structured text. So we've unchecked the Boolean option. We've given it a name here. The qualifiers apply here as well. So similarly to how we had the qualifiers for the Boolean, we can have the qualifiers for the non-Boolean. We choose structured text. And then here you can just type in, so similar to how we had the Graphset, we have the different buttons here where you can create new variables. You can add existing variables, or you can use the different functions to add, you can add in, for example, if I just double click here, it's going to add in some value, some function. Or you can just type it in. So it's the same as for the Graphset, some combination of typing or using the buttons to generate your structured text. And here you see, again, you have the different qualifiers here, so the N, S, L, and so on. They're all the same, so whether it's a structured text or whether it's Boolean, it's exactly the same. For the ladder, so with the structured text, as soon as you create it, as soon as you add the step, you select the action, you can just start typing in your structured text. I just happened to pick one that wasn't a structured text. This one here I meant to pick. So you can just start typing that in straight away. If you go to ladder, it's a little bit different. So let's just create a new step here. We do the same thing. So we'll create an action, non-Boolean, and we go to ladder. So when you choose ladder, what you need to do is you need to choose a diagram. So here we have a list of diagrams. So with the ladder, you need to have predefined your diagram. So these SFC routines 1, 2, and 3, so I'll just close this and remove it. These have been predefined. So if we look at my project explorer here, you can see in this project here, so this is the 61131 project, I have two different ladder diagrams. So if we look at the first one for LD action, you can see in this diagram, I have defined three different ladders. So when I go back to my structured text, to my SFC, you have the three different ladder diagrams that are available. So before creating your SFC, you need to create the ladder before so that you can include it. Now, one thing to be aware of when you're using the ladder is that you use the correct one. So here, in this case, we're looking at the AB500 ladder. So let's just go to the AB500. And you can see here, normally, if you're just doing a ladder diagram independent of the SFC, you just use a power rail. But in this case, we want it to be compatible with the SFC. So we need to use the SFC components here, and we need to select that power rail and just add it onto our diagram here. So now you see I've added this SFC routine 4. I haven't added anything to it, but if I go in here, you can see my SFC routine 4 is now available in there. So you will need to program your ladder logic as you see fit for each of the steps. And once that's done, then when you go back to your SFC, you can select that routine. So here we can delete this. So this is standard ladder logic. I won't go into any of the details on this, but basically this is just you program it depending on whichever ladder technology you're using. You have to respect the standards of the variables and addresses and so on for that. So here you can see as you select your routine, it's shown up in the diagram. If we were to change the routine, so if we choose this here, let's just say we can see here this says routine 1. If I change this to routine 2, you can see that it's changed it here and it's changed all of the different the elements inside. We'll just put this back to routine 1. So that's with regards to the step, that's how you create the actions for that. These also still have the qualifiers, so it's the same thing applies here. When it comes to transition, so here we have, well, we just have a Boolean transition there, but the transition 2 here, we can see we have a ladder associated with that. So that's the same thing. Again, you have to choose the language. So if we just compare here. For this one, we have the language is structured text in this case. You can choose from the drop down from one of the different languages. So in this case, we've chosen the ladder is AB 5000. Here we're just doing the example to show that you don't need to use the same technology. This one here has been done with ladder AB 5000. So you can mix and match whichever modules you have. You can use them however you like in your SFC. So in this case, we can see if we look at the AB 5000, it's exactly the same in that you have the SFC components here that you need to use. And in this case, you still need to use the power rail. So we'll add the power rail in, but you also need to add in the SFC coil. So this coil we've used a symbol which represents a transition in an SFC. So it just looks the same. You will need to use this. So you can see here in what we've predefined, you can see at the end here we have the transition. So this is the last element that gets, when this gets activated, the transition will get activated in the SFC. So if we go back to our diagram here, you can see that the transition itself, the symbol from the ladder, is actually the transition. So the same, we have the transition here, we have the actual ladder symbol is integrated into the SFC. So you can see there our SFC, that's how you would build it using ladder logic. The last thing to look at is the execute operator. So if we look at this one here, which is a structured text again, you can see you can actually run essentially a sort of programming language here. Here we're using if, then, and else. We're using, I think something's happened in this file here. There's a little bit of a glitch there, but we're using case, else. Here you can use for loops, while loops, and so on. So you can do different types of programming type functions in here using the SFC structured text functions. So here you can operate on different variables. And that's essentially it. So just to go back to what's new. So we've gone through, I think, pretty much everything here. Yeah, so we have, just to sum up, we have the different qualifiers that are available on the step. You can do non-Boolean actions, so you can either use structured text here in this case, or ladder diagram. So any of the ladder diagrams we'll use. And we've added new operators. So I hope that's piqued your interest for the new workshops, the GRAFCET and the SFC. And I hope you'll get some use out of those as you use your Automation Studio. Thank you very much for your attention. Bye-bye.
Thank you, Shane. Again, if you have any questions, please feel free to post them using this tool on the questions chat. Let's see here. Okay. Oh, can you guys see my screen? Just to make sure it's running.
No, we just see the default background. Yeah, okay. See it now.
Okay, just to be sure. Okay, so as I mentioned, if you have any questions, feel free. Please feel free to post them in the questions box. We'll be able to answer them during this questions and answers sessions. So we do have some questions here. Can more than one partial graph set be enclosed to perform one or more forcings?
Yeah, so you can enclose with the partial graph sets, you can enclose one within the other. The only thing you need to watch out for is, as we mentioned, is the hierarchical level. So you can force multiple graph sets as long as the one you're forcing is a lower level than the one doing the forcing. But yeah, you can force multiple.
Good. We have another question here. Can we have the example files you showed today?
I guess Bruno Luis shared those. I guess we can share. Well, a lot of the files, they're not you know, like for a lot of the things, they're just demonstrations on the different functions, so they don't really do anything. But I guess we can share them if you want. Yeah.
Mm-hmm. Yeah, maybe I think systematically we won't be, I mean, just putting them all out there. Maybe eventually we'll maybe put them in the maybe a spot there, maybe within the client zone where they can be shared. For now, if anybody's interested in getting a copy of those files, maybe just send us an email. We'll look through to see what's possible to share with you, and we'll be glad to assist. Good. So let's see if we have other questions. Is the color associated with a partial graph set configurable?
For now, no. So the colors are predefined, but we do hope in a future version to make that something that can be edited.
Okay, let's see if we have others. Can I copy and paste a partial graph set?
Yeah, you can. Well, you can see as I sort of did it. Maybe if you want me to show my screen.
Yes, you can.
Let me see. Let me just get the screen again. So you see my screen?
Yes.
So here you have the graph set, this entire graph set. What I can do is if I just drag and drop it, it moves the whole thing. So I can just select just the frame, and that selects everything inside it. If I hold Control and drag it, it'll just create a copy. If I want to just copy the frame or move the frame, I can hold Shift and remove it. So those are the Automation Studio standard key presses for copying and moving stuff. But yeah, just copy, or even just copy and paste, and you can, you know, copy paste. You just need to make sure then afterwards that your steps and your numbers and everything all match up, because it'll create new step numbers and the forcings won't match up. You'll just have to readjust those values afterwards.
Okay, and I see there's also automatic renumbering that's done here.
Yeah, but the forcing, for example, this is not connected to anything because this one was linked here, so you'll have to relink it to some other graph set somewhere to force it, or the enclosure one, depending on which type it is that you're doing.
Okay, thanks. Let's see. Other questions here. Can SFC or Graphset export in codices?
Now, no, I don't think so, but we can take a note of the request. Yeah, it's not. We don't have any exports for this for now. Yeah, but we'll make a note and we can see if there's enough demand we can potentially add in. I don't know the complication. It might be. I don't know much about CODESYS, so we'd have to see what they allow, but we can certainly look into it.
Okay, thanks. Let's see if we have other questions. Can macro representations be used in SFC?
No, macro representation is just a function of Graphset. So the SFC uses a different set of tools. So the macro is only Graphset.
Okay. Another question here. To who I have to send an email for the example files? You can send it to me directly. So I'll get the list of attendees for this meeting. I'll send you a quick email afterwards, so that way you could reply back. My email is bdupuis@famictech.com. So that's btupuis@famictech.com.
I think it's also set, Bruno, that the default reply, if you reply to the webinar invitation, or that it goes to you also.
Yeah, it'll get to me. Yeah, it'll go to another email, but it will get to me. So you can reply to that one as well. But I will send you an email after the webinar. I've taken note. Okay, and last, let's see if we have other questions. Can multiple languages be used in the same SFC?
Yeah, you can. So just let me grab my SFC. Where's my Project Explorer? If we look here, which one did I have? We have even here, this is a simple example, but technically so we're using multiple ladder languages here on this. So one was with the Allen Bradley 5000, the Allen Bradley 500, but even the transitions here, this one is structured text. And if we had, let me see if I had one at the bottom here. Yeah, well, this one here is also structured text. So we're mixing the ladder and structured text. There's no problem at all with that. As long as each element is coherent by itself, it doesn't matter what the previous steps or transitions were, what language or anything. You can mix it as however you feel.
Yep, very good. We have another question here. Is Siemens ladder available to be integrated in SFC?
Yeah, just let me. Sorry, I got to my different project. Yeah, we can have the different ladders. So we have the Siemens ladder, which is available here. So the same way we create, I don't have it. I can't put it on this document here, but no, it's not. No, I'm just looking. Actually, no, it doesn't look like it is. Sorry, a bit wrong. Sorry. Yeah, I think actually, unfortunately, not for the moment. But no, I'm looking at the wrong thing here altogether. So we had we have here for the ladder for this one. We don't have it. I don't think, Jackie, unless you have. We do have SFC Siemens ladder, but I think for now it's not compatible with the SFC.
Okay. Yeah, we'll maybe look into it. If it's not available, we can explore maybe to see what's the feasibility in adding it. Yeah, if you haven't, a lot of these features that we're presenting today, they're new, right? It's part of the what's new that's available in Automation Studio. So these, some of the SFCs is just new standards that have been implemented. So you should see a lot of new functionalities. The integration with SFCs is new features that's been added to Automation Studio. So yeah, as you're using this, if you have questions, because probably more questions will come up, do feel free to email us anytime. We'll be glad to assist you. Let's see, we have other questions. I think that's it. Okay. Well, thank you everyone again for attending this webinar series in Automation Studio 8.0. Again, please feel free to join us again next week. It'll be same time on Tuesday, and for the next webinar, we'll be looking through the new features related to the electrical module of Automation Studio. So thank you so much for your time. And again, this video link will be shared with all registered participants afterwards within the next 24 hours, and we will be posting the webinar video on our website in due time. Thank you again for your time today, and hope to see you again next week. Bye-bye for now.
Bye.